Okay, well, there are more than 80 people here, so I'm just going to give a quick few announcements. So first of all, we are almost done with Unit 1. We're getting very close, and I just wanted to thank everybody for their hard work. I know how challenging it can be, particularly near the end of Unit 1. So definitely pat yourself on the back for making it this far and for persisting. And also a good thing though is we still have enough time to where if you're falling behind, we have plenty of time to catch up. Just make sure and communicate with others about it. Make sure and get with your TAs or myself. You know, being a developer, a big part of being a developer is being able to communicate with others. And so it's a great opportunity to practice that skill. So if, yeah, if you are needing help, definitely reach out. Another announcement I wanted to make is that I will now be available during class time every day, unless otherwise noted. So that'll be the best time to have a back and forth with me is at 5:30 to 8:30 on Monday or Thursday. Yeah, so if there's anything you need to talk to me about, if there are any issues that you're having, or you're not sure if you should talk to your TA or talk to me, you can feel free to send me a Slack during this time, and that'll be the best time to have a back and forth. However, I will not be here on Monday for part of the evening because I'll be helping out with another cohort. But we are having a work day on Monday, so that's a great chance to get caught up and communicate with your TAs now, today, if you need help on Monday, so that way you can get something set up, get an appointment set up. And but prior to the work day, the catch-up day, we are going to have a speaker at 5:30. So Patrick Igwe will be coming in and sharing about his experience. And he is a longtime, very experienced software engineer over at MasterCard, who we have a really good relationship with in terms of apprenticeship candidates. So definitely don't miss that. And yeah, I think that's all I had to announce right now. Thank you for letting me speak for a little bit, Carrie, and I'm going to run over to the TA meeting.
Thanks, Colin. We are happy to have you. Okay, yeah, I want to reiterate what Colin said. If you need any help at all with a catch-up plan or anything like that, just reach out to him. That's part of what he's there for, and he'll be able to, you know, get you organized and try to get you to the finish line here. All right, so tonight we are talking about TypeScript, which is an important little foundational thing for you guys coming into Angular, which is what the last 3 classes will be about. So I've got a couple announcements, and then we'll talk about TypeScript, and then I'm going to do a quick demo for you of what your graded assignment 5 should look like when you're done with it, and kind of how to test it to make sure that it's meeting all the criteria. And then we'll send you off to studio and then come back for studio review. Okay, so as mentioned, there is a catch-up class on Monday, but there will be a guest speaker at 5:30. So come to this main lecture room first. And then after that, you'll split off into your TA groups for your catch-up class. And then graded assignment 5 is due on Thursday, a week from today. The last day of class with lecture is the 15th, and then there will be a catch-up class on the 19th, which is when graded assignment 6 is officially due. And in fact, all 6 graded assignments must have a score of 1.0 complete by the end of that night for you to continue on to Unit 2 when we start on January 5th. So just want to make sure everyone's clear on that. And then we'll get to learn about Java, and it'll be fun. Okay, let's talk about TypeScript. So you guys have learned JavaScript, but we were not assigning types to anything ahead of time, and TypeScript is what takes care of that. So I'm going to talk about the difference between statically and dynamically typed languages, and then we'll talk about variables, arrays, tuples, functions, importing and exporting with ES modules, how to compile your TypeScript into JavaScript so that it can be run. And then how to type objects with interfaces, and how to define a TypeScript class. Okay, so you may remember many classes ago that we talked about the 2 stages of your program running, right? The first stage is for it to compile. And then once it's compiled, the second stage is execution. So this is where we kind of get a little bit of context for what the difference is between dynamically and statically typed languages. With a statically typed languages, the variable types are set during the compiling stage. And so this means you have to explicitly declare them in the code. And that's what TypeScript will do for you. So that's what we're going to talk about tonight. Up until now, you've been using JavaScript, which was a dynamically typed language because the variable types were not determined until runtime. And they're inferred after the code has been compiled. JavaScript looks and says, oh, hey, that looks like it's been set to, a string or a number, and then it assigns the type. So there are, pros and cons to this. Why you might choose a statically typed language would be, to make it really clear for yourself, for other people that are looking at your code, how it's supposed to be used. It's really kind of a form of documentation, but it also significantly helps you with finding errors. So you can catch those errors while you're compiling, which means you can fix them during development and not have to worry about those kinds of errors coming up once it's already out there in production and your user is running into problems. So your code's, more stable. It's more protected against, being broken. So since version 2 of Angular, Angular has been using TypeScript instead of JavaScript. You may see out there references to AngularJS, and some people use that term interchangeably to mean Angular, but it really isn't the same thing at all. AngularJS is version 1 of Angular, way back when it first came out several years ago. And ever since then, version 2 and on, it's been based in TypeScript. They made a major overhaul. So because of that, when you guys are going to be learning the foundations of Angular, it's important that you understand the differences in the syntax with TypeScript and how to declare all of these variables and classes and such. Angular uses class-based component architecture, and so you'll be.
Yeah.
Everybody check your mics. We got somebody with an open mic. Okay. Angular, uses this, class-based component architecture. So you'll be writing classes in TypeScript for that. Okay, so let's talk about typing variables. When you declare a TypeScript variable, you use let or const, just like usual. But then before the equal sign, after the name, you're going to add a colon and give it a type. So here's examples of that. For score, the type is number. So we've got let score colon number equals 0. For greeting, it's a string. For is ready, it's a Boolean. So it's very straightforward. You just insert a colon with the type right there between the name and the equal sign. Arrays and tuples. So arrays you're used to because this is something that exists in JavaScript. All elements, however, must be the same type in TypeScript for you to use this syntax, which is to add a colon with a type plus brackets after the name before the equal sign. So it's just like, a variable, but you're going to tack these brackets onto the type there. So like in this one, the first one, scores, is an array of numbers. So you would give it number with the brackets right after it like that. And that's how you tell it it's an array of numbers. Letters over here is an array of strings. And so this is how you do it anytime you know that every single element inside the array is going to be the same type. But because JavaScript allows arrays to have any type in it, it can have mixed types, right? So the way that TypeScript handles that so that you can set the types is this concept of a tuple. So you are going to add the brackets and then just list the types in between with commas in between is what I'm trying to say. So this example here, let data we're saying that this is going to be an array that has a string, a number, and a Boolean. And so that is how you would do it. I honestly don't come across these like hardly ever, but there are use cases for it. So it's important that you understand the difference. Okay, so typing functions. Let's, we're covering all the basics here, and then we're going to kind of take a look at, expanding on this a little bit. So a function, you're going to use the function keyword as usual. And then within the parentheses where your parameters are set, each parameter needs to have its own type. And then after the parentheses, you also have to give a type to the return value of the function. Now this can trip people up. So I'm going to kind of go over this. And if the function is the type that doesn't have a return value, it just goes and does something for you, changes the value of something else, somewhere else, or maybe just prints, a log or something, you would just use void instead of the type. So let's look at these examples. You've got function addnums, our favorite go-to for examples. Number one is a number, and number two is a number. So those parameters each have their own types inside the parentheses. Then just after that, okay, we'll do both functions, and then we'll go to the other one, apparently. So print book info, same thing. We've got a title, an author, and num pages. Every single one of those parameters gets its own type right there in the parentheses. So that's how you do the parameters. To do the return value types, you're going to put it right after the parentheses before the brackets for your function. So we're saying that this function addnums has a return value that's a number. And in the case of print book info, we have to set it void because the only thing that this thing is supposed to do is just console log something. There is no return value. So you give it colon void instead. Anybody have any questions about that? Yeah, Eric?
Sorry, I was waiting for to see if you answered any questions about arrays. So when it comes to tuples on the arrays, are you able to add things to those arrays? Like if you have an array of numbers, you can obviously add numbers to that, or an array of strings, you can add numbers to that. But if you have a mix, how do you go about adding that? And then part two of the question, if your function returns an object or an array, is that put in the end of the TypeScript as well?
Yes, like if one of these returned a string, an array of strings, then you would use string with the brackets to indicate that. If it was some sort of an object, we haven't talked about that yet, but there is a way to type objects. We're going to get to it in just a little bit. And then you would just put that type as the return type. Yeah. So to your first question about tuples, man, that's a good question. I have not used those like really ever. And so I cannot remember what the answer to your question is. Let's take a look at it. So as many values as needed of different types. Okay, so I think the idea here, okay, hold on. They don't say. Let's Google it. Why not? Can you add more elements to a TypeScript tuple? So it's saying, yes, you can. You can use push. I guess as long as they're one of the listed types, you can. But if you tried to push true, yeah. So I guess what you're really doing there is just saying numbers are cool, strings are cool, but you can't have Booleans in this example. Like if you tried to push true to it, it'll throw an error. So that gives you the flexibility.
So when I'm sorry, when you establish the array, you have to, does the order matter in which you put like the number then string, or is it just saying these types of, or I guess types are available?
That's a really good question. Okay, so I'm going to cover one more thing before we switch over to some code. And then when we get to the code, I've got a tuple lined up. Let's test it. We'll do it in a second. Okay. So let's just talk real quick about importing and exporting. So just for a second, take off your TypeScript syntax hat and let's go bigger and just talk about ES modules, because you guys have asked before, like, what's the difference between using require to import something versus using the import keyword. This is where I'm going to talk about that. And I want to talk about it for both JavaScript and TypeScript, because there actually are some differences in how it's handled. And then we're going to go look at some code that uses all of this. Okay, so you can use this modern syntax with ES modules. And that works for both JavaScript and TypeScript, and VS Code handles it just fine. So you use the export keyword in front of variables or functions to be exported. You can put them right there before the declarations. And then use import and from to say what files you want, or what items you want from which files. And then for multiple items, you want to put export in front of each declaration and use, you can use deconstruction like I've showed you before to grab them each by name when you import them. But for single item, you can actually use export default, and then there's no need for deconstruction because you can just name it directly. So this is a little bit similar to what you guys have already done with using, module exports and require using that syntax. It's pretty similar. But here's where there are some differences between JavaScript and TypeScript. With JavaScript, common modules have to be converted to ES modules. I mean, that's going to be true with TypeScript too. It's just that it does it automatically as part of the compiling for you. But if you're setting up JavaScript files, you have to, there's a couple different ways you can do it. I'm going to show you one way, which is to have a package.json file and to just tell it, this is an ES module. And then with TypeScript, so with JavaScript, you have to include the .js extension on the import statement. Like I'm getting it from this file .js. With TypeScript, you don't put the extension on the end typically. So let's take a look at this in some code. Okay, so I've got some, let me make this a little bigger. I've got some code here. I've got this example ES modules where I've got a data file, a funcs file, and a main file. And then I've got this package.json, and this is where I'm actually saying that I want the type for this entire thing to be, treated as a module so that it will properly let you use this syntax. So we're going to export these two by actually just putting the export keyword right there in front. And then we're going to import, I'm going to export this one too, but this one I want to export as a default because it's the only one. So I'm just going to do export default function. And then when I get over here to main, I can import these as import both variables. Yeah. Import, and the first one I can do, we said that we were going to have, pi, and then also recipe that are coming from, there's the second keyword, and then you just give it, data .js. And then the second one, I set it as the default, so I can actually just say is even from, and then funcs.js, just like that. And so now if I go to run this, and I need to cd into ES modules, and now I can run this. Okay, so node main.js. You can see that it goes ahead and it runs everything, and I get the values that I was expecting to get from each of these. So it's very straightforward. It's nice, clean syntax. It is a little different than, export.modules and require, but not too different. So that's the basics of how to do that. And this is all JavaScript. So when we get over here talking about TypeScript classes, we're going to look at how to do it with TypeScript. Okay, so now let's switch over to this TypeScript basics. This is all the stuff that I had on those slides, right? We have simple variables, score is a number, greeting is a string, is ready is a Boolean. And then here where we had our arrays, scores is an array of numbers, letters is an array of strings, and then data is the tuple. So add that on here, tuple. Okay. So the question here was, somebody wanted to know, could I actually push an additional element into this? We could try it. data.push. And let's just, give it a, testing 1, 2, 3. And see if it likes that. Okay. And I haven't talked about compiling yet, but I'm going to do this real fast. So I have to change directories though. Okay. Yeah. So here we are, learn syntax.ts. Okay. Yeah. So it lets us add that. It totally lets us add this. No problem. So I think that what we were thinking is true. As long as you say these are the allowed types, then you can add anything of those types to the tuple. Yeah, Matthew?
Can you try pushing a number in?
Yeah, absolutely.
Microsoft's answer on that on TypeScript is basically removing those methods would cause breaking changes. So they kind of declined that suggestion from what I found.
Yeah. So now it's adding both. Yeah. So like I said, I mean, there's going to be use cases for where you might do this, where you might allow there to be multiple types in something. The vast majority of the time, I would say you're probably going to be working with, either objects or primitives that are all the same type. So you're typically working with just arrays. Ricky?
What if you need to like make a tuple of like strings and numbers, but you know that you're going to need to add in a Boolean later? Like, how would you address that?
You could, okay, so let's try this then. Let's take this out. And then let's come back here. Yeah, that's interesting. So as soon as I do that, so I think what you can do is put a question mark on it, which makes it optional. And so that way I can go ahead and I can declare it with just a string and a number and not add a Boolean yet. But then I could come back later and push a Boolean into it and it would accept it. Yeah, so there we go. It's right there at the end. Yeah, we're going to talk about these optional parameters in a second when we're talking about objects and all of that, because this is incredibly useful. Do that a lot, actually, having optional types and optional parameters. Okay, so something that I just did, and I moved my slides around, and so now I'm getting myself into trouble. Compiling. I should have gone ahead and talked about this too. So what you saw me do is what I'm about to talk about. When you want to run the TypeScript code, you just make sure you're in the right directory where the file resides, and then you use TSC once you have TypeScript installed. Then you have this available to you. And if you're not sure if you have TypeScript installed, do TSC and then blank -v, and that will tell you if what version it is. And then if you've got a version, you're good. Otherwise, you might have to install it. So TSC is the command, and then you just give it the file name.ts. And then it doesn't give you any feedback. It just gives you your prompt back after a second. And then, but it's created a JavaScript file. So then you can do an ls to list the contents and make sure it's there if you want. But once it's created a JavaScript file, all you have to do is use Node to run it, just like you would a JavaScript file normally. And later on, as you saw me do, I made changes. So then I went and I recompiled it by just doing TSC file name.ts again. And then it overwrites it automatically. You don't have to go and delete the original or anything like that. And then I just used Node again to run it. So I just was switching back and forth between those two commands as I was, making changes to the file and then wanting to run it again. So we can come back to here and I can just do that one more time for you. So, I don't have to make a change, but I will. Let's, put another number in there. So now I've got a change. So I'm going to put in, TSC learn syntax.ts, hit enter. And then if I want to, I mean, I can see it over here is already here because this is not the first time I've done it. So I know that it's already there. But again, ls is anytime you want to look at what's in your directory, you can always do it that way too. And then that's when I do node learn syntax.js, because now it's compiled into a JavaScript file. And that's what I'm actually going to run. And if we will go over and look at the JavaScript, it's kind of interesting. You can see that it's using, its own, it's putting in its own lines of code to, declare these things and run some things. And, nothing here has types explicitly because this is just JavaScript, but it put everything into a format that it could then work with to run it as JavaScript after you had declared everything. But if there had been any errors, it would have caught it. So like, let's say I was to come over here and it's giving me cannot redeclare block scope variable score. That's interesting. I don't know why VS Code is complaining about that. Scoped. Strange.
That
Okay.
was happening to me because I had the JavaScript file open in the viewer.
Oh, interesting. Oh yeah, as soon as I close it, it goes away. That's really odd. I've never noticed that before. Okay, cool. Well, so there you go. If you get weird errors like that, just close the JavaScript file in the viewer and then apparently they go away. Okay, so everything is cool. It's fine. I'm going to just delete this to start over with the JavaScript. Make sure you're deleting the right one. And then let's say we do something like, let's say this, is required. VS Code is giving me a warning here, which is great. But let's say I was actually trying to compile this. So I'm going to come back and do TSE learn syntax.ts. And I'm going to get an error. So source has 2 elements, but target requires 3. Type string number is not assignable to type string number Boolean. So it's holding me to the fact that I said that it was required that there be some sort of Boolean in there, but there isn't. So, of course, if I'm paying attention, I would have seen the little squiggly red line here, and I would have known that before I even tried to compile it. But the fact of the matter is, when you're working with hundreds of lines of codes and hundreds of files, sometimes you don't see that right away. Or if you do, it might be something you thought that you were ignoring on purpose or whatever, but then it causes you problems. So then it catches it when you try to compile it. So this is perfect because now I know I have a type problem that I need to fix before this code is even going to run and work. So I can come in here and I can, put that back and make this optional again. And now when I try to compile it, no problem. And you can see I've got that JS file there now. So I'm going to do the node and run it and we're good. Okay. So that's the basics of, TypeScript variables and, functions. And we're going to build on that now. And we're going to talk about interfaces and classes. So let me get here we go, thing back. Okay, so let's talk about interfaces. Objects, as you know, are not actually data types themselves, but they hold data that have types. It's a structure. So there's 2 different ways that TypeScript handles this. You can write custom types with the type keyword, but you can also create interfaces. And they're similar in some ways and different in others. But unlike classes, neither of them require you to assign values for properties and methods like you would in a constructor. You are just assigning the types. That's all you're doing is saying it's going to have an object, it's going to have these properties and methods, and these are going to be the types. So yeah, it allows the type declarations, and then it's very helpful for letting you know if you've accidentally left off properties that you were supposed to include for something, or maybe you added a property that shouldn't have been in there, or maybe it does need to be in there, and so you have to update your definition of your type. But either way, both of those kind of help with that. So We're going to focus on the interface because it's kind of closer to what you need for use with Angular, because it kind of intersects with classes, but they both have pros and cons. I would love to teach you about the custom types, because I've used that a lot, especially with Svelte and TypeScript, but it's outside the scope of the course. We just don't have time. So we're going to focus on interfaces, and that's fine. But if you are interested in learning about the difference between the two and digging into it a little more, you can just Google TypeScript interface versus type, and you'll probably get some great information on the distinction between the two. Okay, so let's talk about interfaces. You can use the interface keyword, just like you would to declare a class or something or function. And then you give it a name using the Pascal case convention, also similar to a class. And then you list each property with a colon and a type followed by a semicolon. So this is, how you're used to doing this now. You're giving, names, colon, type, right? So in this example below, you can see that I've got this interface book and the keyword interface, and then all the type declarations for title, author, num pages, and series. And, 3 of those are strings and 1 of them is a number. So now we have a kind of boilerplate for objects that can be, created so that they're all consistent and all have the same properties. Although you'll notice that the 4th property, series, is optional, right? Because it's got that question mark after it. So that means that we could include it or we cannot include it, no problem. So then when you want to go to actually assign it to an object, you are going to, hold on. Oh, right, optional property, there you go. Yes, you're going to declare your object as usual with let or const. You're going to use the name of the interface as the type for that. And then anything that's optional can be left out, but you'll get an error if something is required and it's missing. Super helpful. So in this example, we've got, let current book. Oh, right. Yeah, I mentioned this already. Adding a new property that's not in the interface will also cause an error. So you get errors either way. In this case, book is the name of the interface. We're treating it as the type. So we're saying that current book is of type book, essentially. It's based on this interface. So we're expecting that it's going to have all of the required properties and possibly, any of the optional ones. So there we go. So yeah, so you see the title, the author, num pages, they all correspond there, and they're the right types. Title and author are strings, num pages it's a number. So if I had tried to put num pages, if I tried to put that 238 in quotes, it would give me an error, tell me it's not the right type. Because maybe down the road I'm going to calculate something with a number, and it's important that it needs to be a number. So this is kind of it'll hold us to that. Drew, you got a question?
Yeah, I was wondering if you can or ever should have a default property. Is that possible on interfaces?
You mean default values for them?
Yeah.
No, if you want to do that, then you have to set up a class instead, because interfaces are not intended for you to be setting values on anything. It's just to give everything types.
Okay, thank you.
Mm-hmm. That's a good question. Grant?
Yeah, I was just wondering how does it handle this when it's compiled? Like, is this just creating a new book, or like let current book equal new book object? Or how does
Yeah, so it's just going to create the object, and it's going to just, before it allows it to be compiled to JavaScript, it's just going to make sure that every single one of them that's required is there, and that every single one of them is the right type. And then it'll create the object. It's just a regular JavaScript object. What you're talking about is classes. Like if you actually have an instance of a class, and so then you actually do have, it has all the underlying behavior of a class. So let's actually just look at this. Let's look at how to do this. So I'm gonna skip over to here. We're done with all of this. And I'm gonna come over here to the interface examples. And let me just CD, I don't think, I don't think I'm actually going to run anything. So let's just get rid of that. Okay. So we've got this interface book that we just talked about. And I've got this current book, same as I did, but we haven't typed it yet. So I'm going to actually give it the type book. And if we wanted to, test this and create the JavaScript, we actually could. Let's just do that since you asked about it. So I'm just going to console log current book dot title. That'll give us something to see in the console, but all right, so I need to get my console back and I need to cd into interface examples. No, TypeScript interfaces. Okay. So I'm going to tsc my interface examples.ts. That's going to compile the JavaScript file. And then we can come over here and we can look at that. And you'll see that current book is just set up as an object. It's that straightforward. Basically, it just allowed it to exist as a correct object because it verified that everything that was supposed to be there is there and everything was the right type. If we actually go in and let's do what I talked about before. Let's make this a string instead of a number. I mean, you can already see VS Code is saying you can't make a number a string. It's not supposed to be a string. It's supposed to be a number. And if I do try to compile it, I'm going to get the same, error. And it's going to point it out to me. It's on line 4. On line 4, it says that numPages is supposed to be a number. So, on line 12, you're trying to make it a string and it can't be a string. So it's not even going to let the JavaScript be created at all. So this is the value of this. So now I can go back and I can, undo that and it'll compile again. And then I'll have, a proper JavaScript file. Okay, but let's go to this next one. We've got last book and we're going to, try to type this as a book. Well, we're getting an error. And it's saying, property numPages is missing because it's required in type book. And so, and it points it out, you have to go to line 4 and that's where it's declared. So we look up at line 4 and go, oh yeah, that actually is required. So we can add that in here. NumPages and give it, and I, totally didn't look this up. Let's just go with 400 because those are really big books. And I have, I've used this optional one, right? No problem. So it's there. And now I don't have an error anymore. And then same thing here. I can go to this one and assign it as type book based on that interface. And now I've got an error down here and it says you can't take this type and assign it to book because format doesn't exist. That's not a property that we are familiar with for this interface. So there's kind of 2 decisions to make here. It's like, oh, well, maybe I wasn't supposed to have this here at all. But let's say we say, no, I want to be able to start including this on some of my objects that are based on, a book type. So then we can come up here and we can actually say, we're going to add another optional parameter that's going to be format. And we'll say, string. And now that that's there as an optional format, our errors are gone. And this now works just fine. Okay, does anybody have any more questions about that? We're going to talk about classes next. You good? Okay. All right. So let's go on to classes. Defining a class. So you use the class keyword just like normal, Pascal case. But then you, on all of the properties, before you do a constructor, so this is where it's very, very different from JavaScript. Before you do a constructor, you actually list out all of the properties at the top there, and you give them a type. That's all you're doing is typing them. You're not assigning values necessarily, but you can assign default values here if you want to, and that is a big difference between an interface and a class. And you don't use the keyword let. Notice that. In this case, it's when you're setting up a TypeScript class, you don't use the keyword let for your properties up here. And then you have your constructor, and then you set your parameters, and each of the parameters needs to be typed because those are variables that are going to accept values coming in when you create the class. So we're saying that to create a new instance of this automobile class, we have to give it a year, a make, and a model. We don't have to give it, features or anything like that. I actually think I changed my example in the code now, so we'll see. But in this example, if we had this features, it exists, but it just initializes it to an empty array, and you're not actually passing anything in right away. So let's see, I've got one more bullet point. For the constructor, each parameter should have a type, but the property list inside the body does not. So down here, where you're actually just assigning the values that come from the constructor to the properties, this.year, there's no need to have any types here because you've already typed them up here. And these have already been typed here. And this is just where you're assigning them to, one to the other. So that's the basics of that syntax. There again, there's the keyword. Here are the property type declarations. And there's the parameter type declarations. Grant, you have a question?
Yeah, this is probably pretty obvious, but if I make my parameter for year or make or a number,
Yeah.
but I want, or I make it a string in the parameter, but it's expecting year to be number when you actually assign that, will it handle that conversion for you? Or do you have to have your parameter matching up with your property type declaration?
That's a good question. It's very possible that I'm guessing you have to like very explicitly convert it. If you wanted that to happen, we'll find out in just a second. I'm going to bring this code up and we can experiment with that. That's a very good question. But before I do, I just want to talk about methods real fast here. So you would declare a method just like you do a TypeScript function, but you just don't use the function keyword. But so you give it the inside the class, you've got your property type declarations and your constructor, and then after the constructor is where you declare your method. So we've got this method print details, and it's got a parameter vehicle. So we give a type to the parameter, and then after that, we give the return value of the entire method a type. So just like a TypeScript function that we've already talked about. Your parameters and the return value of the function itself have to have types. And then that's it. And then, inside here, just like a JavaScript class, if you're using properties that belong to the object, you're going to use, this.year and this.make and this.model to refer to things from inside the definition of the class. Okay. Should we switch over? Let me see. Yeah, let's experiment with this, and then I'm going to go talk about and talk about inheritance. But let's look at this first example here. So I kind of set this up where it had this, this dot features, and then later I decided to have an interface that was for features. So this is actually kind of superfluous. I'm just going to take it off. But to your point, you were saying, like, what if we wanted this to be a string, actually? Is this the direction you wanted? Pass in a number, but make it a string?
I was thinking
Other way around?
other way around.
Yeah, well, you can see we got an error with that. Let's try it the other way around. I'm pretty sure it's going to get an error. Oops. Try that again. Yeah, so we get an error either way. So I think what you could do here is you could say number, year. Yeah, and then it would accept it as long as you explicitly convert it.
Thank you.
Yeah, it's a very good question. Because there probably would be use cases for something like that, possibly. I think we try to avoid those kinds of things, but it's possible. Yeah, Yeah, and I think that makes a good point too. You know, these things coming in, you can assign them however you want to the properties of the class. They don't always have to be, you know, exactly the same thing. I think in your book, there's an example where they like have the parameters of the constructor are like first name and last name, but there's no first name or last name properties. The property is name, and they actually just concatenate them together to make the name. So you absolutely can, you know, make modifications to whatever your parameters are for the constructor to actually assign values to your properties. It's a very good point. Okay. And it's still complaining about something, but I don't know why. Oh, down here because of, yeah, okay, that's fine. I'm going to undo this just because it's going to start messing with my other stuff in a second. Okay. Let's go to the next slide. I want to talk about inheritance and how to implement an interface with a class. So TypeScript classes can inherit properties and methods from a parent class with the extends keyword, just like JavaScript. So you should be familiar with this. But you can also incorporate properties and methods from an interface using the implements keyword. And you can see here, I've got an example where I'm actually doing both at the same time. I've got my class and I'm naming it truck. And I'm saying that it extends the automobile class. So automobile is the parent of truck and truck is the child. But I'm also implementing an interface. And if I'm pretty sure you can extend one and implement one interface, and that's it. You can't like keep doing this forever. So you would have your property type declarations at the top, then you would have your constructor, and then you would have new or alternate definitions of methods for truck as the class that you're actually defining. So let's look at examples of that in our code. I've created this interface features. It has properties, paint color, interior, and an optional property called miscellaneous. That's an array of strings. And then I have this truck class that extends automobile and implements features. So couple things going on here. First of all, truck has its own properties. It has cab style and engine. So I've got those, you know, typed up here, and then I have them, you know, listed here to actually take values from two new parameters. So we have the original parameters that are inherited from the parent, year, make, and model. And as you can see, I'm using the super constructor here to, you know, kind of mark those as saying, take the values from here and feed those into the constructor from the parent. And then now we add on the two new ones. But then you'll notice that because an interface doesn't have a value assignment, you have to do the same thing for the ones that are coming from the interface. So I've got, you know, this dot paint color, this dot interior, this dot miscellaneous, because those now need to be assigned for this class. And because none of them are actually listed in the parameters, I need to give them, you know, default values of some kind. So I've done that. But I also had to explicitly declare them here. Unlike the ones that were inherited, because that was already done up here in the class. And I'm not entirely sure why you have to redo it for this, but I found I was getting errors when I didn't have them in here. Drew?
Yeah, I was just gonna ask, isn't that kind of redundant? Like,
It is.
why do they, what's the point of even making the interface then?
Well, the interface can be used for a lot of other things. It, you know, that it's that you may not, having it as part of the class may not be the only reason it exists for you. You might use it for other things as well.
Okay.
But yeah, I do think it's interesting that it makes you do that, but it does. So you may not use this super often. You're actually going to do, you're going to be working with an interface tonight as part of your studio. I'm not sure if you're doing exactly this. I need to go look at that, but I'll have it all figured out by the time we do the review. So yeah, so this is basically how you would, and then down here, what I've done is I have a new definition for print details that's more involved because I have new things, new information I'm working with. It's not as simple as the way it was declared here. So I'm, giving it the exact same name as the inherited method. And it has the same parameter, but I am actually, building it a little bit differently before I log it to the console with all these extra details. So that's how you do inheritance. And then the last thing to do here is to export. So this is exporting and importing. This is how we're going to talk about the slight differences with TypeScript for this. So same thing here. I'm going to say export default. And I'm going to do something I haven't done before, which I'm going to have both a default export and then also non-default exports here. Export class truck. And then I'm going to show you how to do both at the same time for your import statement. So we go over here to index, and I've got, where I'm trying to instantiate these, a new car and a new truck from these classes, but they haven't been imported. So I'm going to say import, and then I'm going to say automobile without putting brackets around it because it's a default. So it gets imported directly. And I'm going to have a comma, and then this is where I'm going to use the deconstruction for the one that's not a default and say truck, and then from. So you might see this, especially once you get into the real world, you'll see this kind of stuff all the time. And then I just do, from automobile, but I don't say .ts or .js. And that's important because the TypeScript file is going to then compile into JavaScript. So you don't specify. You just give it the name, but it knows, it knows what it's looking for. It's because it's going to need to be, eventually it's going to be, using it as JavaScript. And once I do that, we're going to see some interesting stuff when we compile the JavaScript file now that I've got all this set up. But you can see all my errors went away. It recognizes it now. It looks like everything's good. So let's try compiling it and see what happens. Come down here and go into TypeScript classes. All right, so we've got automobile.ts and index.ts. Those are the two files we have. So I'm going to do TSC, and I'm going to do the file that I'm actually trying to run that is importing from other files, and that's the index file. And when I do that, now we see we have 4 files. It's created a JavaScript version of automobile, and it's created a JavaScript version of index. And so we can go and we can take a look at these new files, and you can see here, it's got a whole lot of syntax in here that looks very, very unfamiliar to you. But a couple things I wanted to point out is, this is where it's actually saying, yes, we want to convert this to an ES module. Yeah, it's taking care of the way that the exports are handled. And then it's adding truck as, one of the things that's actually in that object that we're deconstructing when we import it. So over an index, you can kind of see the same thing. It's, making sure that it's logged as a ES module. And then it's using the require syntax that you guys have used in the past, which I find fascinating. But yeah, so there's a lot of stuff going on here where it knows what it needs to do in order to run it. And you don't have to worry about all this stuff. You just have to do basic TypeScript syntax, and it creates all of this automatically for you. So that's a wonderful, wonderful thing that, it has a lot of complexity to it, but you don't have to do that. It does it for you. So let's, I've compiled it. Let's try running it. Let's run index.js with Node. And we get our 2 statements. This SUV is a 2007 Ford Escape. This truck is a 1986 Chevy S10. It has an extended cab and a V6 engine. So our, over here in our classes, these print details methods that we defined, everything came out exactly as we expected. This one had all the extra information. Okay, any questions about this? Brad?
Yeah, so I get how this works when we're hard coding this data, but how would TypeScript work if I'm using an API or pulling this from a database?
when you, that's a really good question. Trying to think if I have I've got an Angular example, but if you are fetching, let's say you fetch and you are wanting to extract the data and you've set up a class that is going to kind of like have all the properties and you want to pull the data from the JSON and make new instances of your class and you assign everything, you would do it just like you normally do, where you would, use the constructor. So you would do just like this, only these values might be something like, from your JSON. It might be like, data.year and data.make and data.model or something like that if it's coming from the JSON.
Got it. But TypeScript wouldn't have anything to help, like if the year was coming over as a string, it wouldn't help me. I'd have to implement error handling in my code.
Yes, exactly. And ideally, you're going to be, planning for the data coming the way it's supposed to be coming. So
Got it.
every once in a while, like I've had instances where I've run into stuff and I've had to like talk to one of the backend guys on the team and say, hey, this data is not coming in the way that you think it's coming in. There's something going on. But maybe I'm the one who has to adjust things and I have to allow for it to come in because the backend guys are saying, nope, this is the way it's going to come to you. So you just have to, make it what you need it to be on the front end.
Got it. Okay, thanks.
Okay. The last thing I wanted to do, now that we have gone through this, is hang on. Oh, yes, I'm going to demo completed graded assignment number 5. Okay. So I don't have this up in front of me, but I can get it. Let's go to assignment number 5. Okay, so launch checklist forms. They tell you that you want to, load in some, you're going to fetch some JSON and load in the planetary data in this box up here at the first box. This middle box is a form, and that's where you're going to, use your knowledge about the DOM and form validation to make sure that the user is only putting in, actual words like text, alpha characters for your names and only numbers for your fuel level and your cargo mass, and your submit button is working properly, and that certain messages come and pop up at different points. And then down here, this information is going to change depending on what's been put in. So they'll tell you, they've got some like helper functions for you that you can write for like validating input and things like that to help you kind of work through this process. And they give you this reminder, which we've run into before, that if you want to check if something is not a number, you can't use the loose equality or equal strict equality operators. You have to use this is not a number function, this little method that will just return true or false, and that lets you know if something is not a number, and that will be helpful for you with that validation. So the basic requirements here, you're going to have a whole bunch of conditions. This is the word I'm looking for. Conditions, whether the shuttle is ready or not for launch. Wow. And you're going to want to make sure that the values, all of your logic kind of lines up. And then, you're going to very systematically change the color of the text and the text itself for each one of these little elements on the page using, DOM objects. And no matter what's going on, you got to make sure that all of them update to whatever they're currently supposed to be. I think a mistake a lot of students make is thinking they only have to update the one that's relevant, that's actually needs to change. But you have to remember that you could have just come from another situation where something was, set another way. And so now you have to change it back. And if you remember from the lecture example I did where I had the little business card examples, when I was changing things, I was changing every single one of the properties every single time to make sure it went to what it was supposed to go to. So keep that in mind. Okay, so lots of little instructions in here, and I'm trying to find the part where it tells you about the numbers. Okay. That's okay. So I've got this example in here. I'm going to refresh this page. The bonus mission, does it still have the bonus mission? This is from a long time ago, but here we go. Okay. Maybe they just require this now, but originally and I apologize, I didn't read this through more thoroughly before, guys. This was kind of a last minute request. I've got this set where it's choosing a random one from all the JSON from the array each time. So every time I refresh the page, it's probably going to be a different one. And yeah, so, but I'm listing all the information. It gives me the image. Since you guys did the astronaut thing, you know, for Studio last class, you're going to be pros at this part. Shouldn't be a problem. Okay, and except that you only have to list one of them. So then the form, I can put in, you know, Jean-Luc Picard and Will Riker as his co-pilot. And I can say that there's, you know, 10,000 gallons of fuel and the weight is, you know, 5,000 and submit it. And it says shuttle is ready for launch. And it says pilot Jean-Luc Picard is ready, co-pilot ready. Fuel level's high enough, cargo weight is low enough. So then if I go and I actually start testing this, and this is what you should do. You should do a lot of manual testing. Let's say that I say that there's a, you know, fuel level of 100, right? Now this switches and says shuttle is not ready for launch. The pilot and co-pilot are still ready. They're cool, but there's not enough fuel to launch, but the cargo weight is still fine. So these should always reflect exactly whatever situation is going on up here. If I change this back to 10,000, you know, plenty of fuel, but what if the, you know, weight is like, you know, super massive? Then it says it's not ready for launch still. And at this time, it says cargo is too heavy to launch. And I wonder if that's actually, yeah. And then when I change it back, and put everything, you know, it goes green again and everything changes to say that it's, yeah. But I can't put in like, you know, one, for that, it's going to warn me with an alert and say, oops, please check that you've entered valid names for both pilot and co-pilot. So there's going to be a number of different things that you're putting together from several classes worth of learning here. So you're fetching data and displaying it. You're doing form validation. You're responding to, you know, click events and then displaying things conditionally down here in this box. So just kind of be thorough, make sure that you're, you know, checking kind of all the different cases you can think of for, you know, different types of input or whatever that you're validating it, and that you're always getting what you expect to get down here when you submit it. Any questions? Okay. All right. I'm going to send you guys off to Studio. Let's take a look at that real fast. You're going to, you may have already actually forked and cloned the thing, because for this chapter, they have the exercises in the Studio in the same repo. So if you did the exercises, you're already going to have the repo. Now it's just time to do the Studio part. Otherwise, you'll need to fork and clone it, get it on your local machine. And then you're going to write some TypeScript classes and use an interface, and you're going to run it from the terminal. So you'll need to compile it and, you know, run it with Node like I showed you. All of that is, you know, here in the instructions. So I'll get those back here. Yeah. So just make sure that you are in this Studio, you know, folder inside the repo before you try to compile your TypeScript file, because otherwise it's not going to know where it is. But yeah, you've got 3 different classes: astronaut, cargo, and rocket. And you're going to, you know, run everything from the index file. So you'll import those. And then you're going to also use an interface named payload to make sure that certain bits of data have the right properties consistently. So that's the way you'll type those objects. And then it walks you through this step by step. So this is pretty straightforward. And you guys, you know, working together, especially, you should get right through it. They give you all of this code. They literally say, just paste it in. Okay. So you don't have to write all of this. You just use it. they really want you just to focus on the, creation of the classes and all that kind of stuff. And then it tells you exactly what to expect in the console output. After you compile, it walks you through the compiling process. So this is good. This is straightforward. You guys should be cool. So you head off and do that. And next class is catch-up class. And then we are going to start getting into Angular next Thursday, a week from tonight. It'll be super fun. Angular's great. All right. Have fun in studio. We'll see you back here at 8 o'clock.